This is the second in a series of videos on Introduction to Exponential Functions. And let's start this one by looking at the basic form of an exponential function. That's y is equal to a times b to the x, where a and b are simply real numbers, and b is greater than 0. And x and y are the variables. But let's rewrite this in a slightly different form. Let's rewrite it y is equal to a 1 plus r raised to the x. Because when we write it this way, each one of these have a real-world application that's very straightforward. So first of all, let's look at the a. A here is simply the starting value. So whenever we talk about exponential growth or decay functions, we always talk about what we start with and how it changes. So this is the starting value. The R tells you the growth rate. X is the number of time periods. And y is the ending value. So let's look at an example real quick. Let's say we have the function y is equal to 105, 1.23 raised to the x. Well, first we look at a, right? We're writing this in the form y is equal to a 1 plus r to the x. So a here is 105. So in other words, you start with a value of 105. R here, well, 1 plus r is 1.23. So if you subtract 1 from both sides, you get r is equal to 0.23. And that's a growth rate of 0.23. Or if we want to put that in percent terms, that's a growth rate of 23%. X is the number of time periods. Now the number of time periods is specified in the details of the problem, but the math it's kind of built into the equation, so it doesn't matter in terms of what the math is. And then y is the ending value. So the first thing I want you to pay attention to is let's look at r here. R is either going to be a positive or a negative number. And in this case, r is a positive number, which means it has a positive growth rate. So let's look at our basic situation again. Y is equal to a 1 plus r to the x. So if r is positive, then that's called an exponential growth problem. It's an exponential growth function because you have a positive growth rate. And if r is negative, that's called an exponential decay problem. Because you have a negative growth rate, or sometimes that's called a decay rate. And the first questions you'll be asked is to simply look at exponential functions and describe them. Let's give you an example. Let's see if y is equal to 12, 2.5 to the x. Let's see what we know here. The first thing we know, this is an exponential function, right? The way we know it's an exponential function is because it's written in the form y is equal to a times b to the x. But is it growth or decay? And the way we tell if it's growth or decay is we take this number right here, 2.5. If it's greater than 1, then it's exponential growth. And if it's less than 1, then exponential decay. So we can write that rule down real quick. y is equal to a times b to the x. If b is greater than 1, it's exponential growth. And if b is between 0 and 1, it's exponential decay. And in the next video, we'll start graphing exponential growth and decay functions, and it should be real obvious what the difference between the two. So in this one, this is 2.5, since this is greater than 1. So we say, since b is greater than 1, this is exponential growth. And that's the first thing you know. Then let's look at the starting value. A is 12, so that's the starting value. Let's look at what the growth rate is. The way we find the growth rate is 1 plus r is 2.5. So if you subtract 1 from both sides, you get r is equal to 1.5, and that's the growth rate. So the growth rate, r, is 1.5. So that's a growth rate 1.5, but usually we put it in percent term, that's 150% growth rate. So if you notice, when we look at exponential functions, one of the real useful things about them is that you can look at a function and immediately describe it. Here, we know this is exponential growth. We know the starting, because this number here is greater than 1. We know the starting value is 12, and we know the growth rate is 1.5 because we take this number b and we subtract 1 from it to get the growth rate. Let's do another example. Let's do y is equal to 103, 0.87 to the x. Let's go step by step. First, is this growth or decay? Well, the question is what's this number right here? Is this number right here greater than 1 or less than 1? Right? And that number is less than 1. So let's look at our rule again. The rule is if you have it y is equal to a times b to the x, if b is greater than 1, it's exponential growth. But if b is between 0 and 1, it's exponential decay. And this is exponential decay. Second step is what's the starting value? The starting value is simply a. So here the starting value is 103. And the third thing is what's the growth rate? Let's see, the growth rate here, to find the growth rate you take 0.87. That's equal to 1 plus r, right? But we want r, so we subtract 1 from both sides. But r, we could just do it on a calculator real quick. Minus 0.13. So there's two different ways that we can say that. You can either say that it has a growth rate of minus 0.13 or minus 13%. Or you can say it has a decay rate of 0.13 or 13%. So those two are actually equivalent statements. So to say it has a growth rate which is negative or a decay rate are exactly the same thing. And neither one of these is particularly better. So now what you want to do is let's do 3 problems, and you can just check your answers on the next one. So in each one of these I want you to identify the function as exponential growth or decay. I want you to identify the starting value. And I want you to identify the growth or decay rate. And here are the problems I want you to do, right? The first one is y is equal to 109 1.43 to the x. And the second one is f of x is equal to 80 0.96 to the x. And the third one is y is equal to 12 5/3 raised to the x. So why don't you do those three problems in the next video, you can check your answers.